to my limit series. Today, we will prove the squeeze theorem. Now, the squeeze theorem states the following. So first of all, we assume that f of x is less than or equal to g of x, which is less than or equal to h of x for all x. And we assume that the limit as x approaches x naught of h of x is equal to the limit as x approaches the same value of f of x. And let's say that's equal to L, right? This limit exists, and these two limits, we have f of x and h of x, are equal to each other. So if we assume that these two things are true, then surely the limit as x approaches x naught of g of x is also equal to that same value, L. Now, for kind of an intuitive proof, a visual understanding of this, I could draw each of these functions, or an example of what they could be. So here I have a graph, and we have our f of x. So let's call this f of x. And let's say that we have an h of x as well. Then if I were to go in and insert a function, right? If we had a g of x that was in the middle, the only way, right, it could be less than or equal to both these functions, or the whole domain, is if the limit was this same x naught value. Now that we have an intuitive understanding, we will use the definition of this limit to show why the limit as x approaches x naught of g of x must be the same. So, given the limit that we are assuming, we can say the following. For all epsilon greater than 0, there exists a delta, and we can call this delta A, that's greater than 0, such that whenever x is within delta of x naught, so 0 is less than the distance between x and x naught, which in turn is less than our delta, that this implies two things. That h of x minus L is less than epsilon, and that f of x minus L is less than epsilon. Where, of course, both of these differences are in absolute values because we're specifically looking at the distance. And now we have the limit that we want to prove, right? This is the limit as x approaches x naught of g of x is equal to L. So what does this mean? This means that for all epsilon greater than 0, there exists a delta, which we need to find, that's also positive, so that whenever x is within this delta of x naught, that the implication is that g of x minus our L is less than epsilon. So now we want to prove this limit, right? So first, let's assume that our delta, right? Or let's suppose our delta is the same delta from before, right? That it's this delta A. So we can suppose that delta is equal to delta A. Then we have access to this information here. So then we can see that if the absolute value of h of x minus L is less than epsilon, we can say the following. We can say that negative epsilon is less than h of x minus L, which is less than epsilon. And for a justification on that, the absolute value, right, is either the same thing that's in the inside if it's positive, or if what's in the inside is negative, then you multiply it by -1 to get the value. So if h of x minus L were less than negative epsilon, it would be negative because epsilon's always positive. And we would multiply it by -1, and then it would be greater than epsilon, and that wouldn't make sense. So this is kind of a natural extension of the absolute value. So we also know that g of x is less than or equal to h of x. So that means, right, if g of x is less than or equal to h of x, then surely g of x minus L is less than or equal to h of x minus L. We're just subtracting a number on both sides, so the inequality is still the same. Of course, h of x minus L is less than epsilon, right? We already know that here. Now we don't know the relationship between g of x minus L and negative epsilon. At least we don't know that yet. But we at least know that this difference is less than epsilon, right? Because of transitivity. Now we can show a similar thing, right, with our f of x minus L in absolute values. It's the same thing as saying, well, negative epsilon is less than f of x minus L, which in turn is less than epsilon. And again, we know that f of x is less than or equal to h of x. So therefore, it would be natural to say that, or not h of x, it's less than or equal to our g of x, which is the limit we are trying to prove. So our f of x minus L is less than or equal to our g of x minus L. We're just subtracting L on both sides. And of course, we know that our f of x minus L is greater than negative epsilon, right? Again, this just follows from what we are assuming. So we have that g of x minus L is greater than negative epsilon, and it's also less than positive epsilon. So let me rewrite that over here. That negative epsilon is less than g of x minus L, which is less than epsilon. And if you see what we have here, right, this is the same thing as saying that the absolute value of g of x minus L is less than epsilon. In fact, that's what we were trying to prove. So therefore, we have proven the squeeze theorem. Thank you very much for watching.